Okay, welcome back to another video. In this video, we'll be discussing about chemical equations. Mainly, we'll be talking about chemical equations, the way to write them in the symbolic form, symbolic equations. We would not focus on any word equations. So we'll look into how to write those symbolic equations. Now, parallel to the symbolic equation, we'll also learn how to balance chemical equations, because unlike the word equations, when you write symbolic equations, you definitely need to balance the chemical equation. So let's see what these balancing chemical equations are and how do we do it. All right. So symbolic equations are basically writing the chemical equation of the chemical reaction using the symbolic notations of the elements. Okay, now with the periodic table, you find all the symbols corresponding to an element. For example, uh, sodium is represented by symbol as capital N and simple A. So so all those are there in the periodic table, and for your syllabus you just need to know the first 20 elements of the periodic table. So you need to know them very well. All right, you need to know them very well. uh, for example, you need to know, for example, if you say potassium, then you need to know what the symbol is. All right, so it's a few amount, just 20. So just by heart all of them. And then we need to learn a new term called valence electrons. So basically, those are the electrons that participate in a reaction. Those are the electrons that would be given to an element or shared with another element, or maybe even an element would accept valence electrons of another element. Okay, so that's valence electrons. How are they shared, how are they given, how are they accepted, we won't be learning in this lesson. We will be doing it in the next lesson, but here we'll just go through a rough idea of how to write these symbolic equations. All right, no mechanism will be discussed in this lesson. All right, so let's go into this table. There's a table that we need to know. uh, in this table you can see we have classified groups from group 1 to group 7. You would see that I have not used any you have not indicated the group 8, because the group 8 actually does not take part in any reaction. They are unreactive metals. Okay, the reason why they are unreactive is because if you see, each of those elements have complete outer shell electrons. Their outer shells are complete. All right, so why do these groups react, elements in these groups react? Because they want to achieve that stability. All right, so elements react with other elements to achieve the stability. All right, so the stable ones do not react, they are unreactive. So any example for unreactive elements? Those are all the elements that you can find in the group 8. All right, all those details, you will learn all those groups in detail in the upcoming videos. All right, so the important thing here is you would need to know the number of valence electrons. Now you can see that this valence electrons is basically the another name that is given to the outer shell electrons. Without saying outer shell electrons, we can just say it as valence electrons. So you can see group 1 has 1, group 2 has 2, group 3 has 3, 4 has 4, 5 has 5, 6 has 6, and 7 has 7 valence electrons. All right, now these electrons have a charge. Okay, they will have a charge, they possess a charge. Why do they possess a charge? Because when they give away these valence electrons, or when they accept any other valence electrons, they will possess a charge. Okay, so for example, elements in group 1, 2, and 3. Okay, Remember, elements in group 1, 2, 3 are all metals. So in other words, we can say metals will always give away their electrons to become stable, and they obtain a positive charge. So metals or the elements found in group 1, 2, 3 will give away their electrons in its outer shell, or they will give out their valence electrons to other elements, and they will achieve a positive charge. Whereas the elements in group 5, 6, 7, which are non-metals, will accept electrons into the outer shell and become stable. Okay, and they will indeed have a negative charge. Okay, so that is the difference between these two. Okay, so that's why you can see, so from group 1 to group 3 you will have positive charges, and from here to here you will have negative. So basically this group 7 obtains one electron, it accepts one electron. Group 6 accepts two electrons. Group 5 accepts three electrons. Whereas group 1 to 3 will see, group 1 will give one electron and obtain this charge. This will give away two electrons and obtain a positive charge. This one will give away three electrons and obtain a 3 plus charge. Okay, so group 4 is also will be 4 plus. Okay, we'll not talk about much about group 4 because it is not very necessary, very whereas the other 6 groups are extremely important to discuss. Okay, now valency is basically as I said earlier, it is the outer shell electrons. Okay, but these in this periodic table I told you there is a portion called the uh, transition metal portion, this portion. Okay, so this portion is actually the transition metals. Now transition metals, they do not have an exact valence like +1 or something like that. They don't have a exact charge or exact valence electrons. It changes. So for example, but now for example here you can see iron. Iron has a valency of 2 and a charge 2 plus. Also iron has a valency of 3 and a charge of 3 plus. So you see they vary. So if you see iron, the symbol for iron is Fe. Fe is found in this block, which is the transition element block. So it will possess valency of 2 or 3. So copper and zinc will also possess a valency of 2 and a charge 2 plus. It can possess other charges and other valency also, but for your syllabus, these are the most important things. Apart from the elements, apart from the 20 elements in the periodic table, you might be also given these elements. Okay, so these elements are the only elements that will be tested outside those 20 elements. Okay, so altogether you need to know about 23 elements altogether. A simple amount, right? Not a big fuss. All right, so 20 elements means you have to learn up to calcium. So if you start from here, you need to know this row, this period, argon, potassium, and calcium. So until calcium, you need to know. All right, calcium, and then you need to know about iron, copper, and zinc. That's it. Nothing more than that will be questioned in your exams. All right. So now let's go to an example. Let's look into some. Let's look into some examples of this symbolic equation. Now I said sodium. If you look into the periodic table, it has a symbol as Na, and this 11 is the proton number. But when you are writing symbols, symbol given, but the only thing you need to know is this symbol. Okay, and so we are trying to react a reaction between sodium and chlorine. Okay, so when we are reacting sodium and chlorine, sodium falls into group 1 and chlorine falls into group 7. So if you can remember, you can go back to the slide and see. sodium, as it falls in group 1, will have a charge of +1. Whereas chlorine, which is in the 7th group, will have a charge of -1. So what happens in this valence when these two react? They will exchange. They will exchange. So this guy will get this guy's one. This guy will get this guy's one. So basically, they interchange or exchange their valences. So in this case, now when we exchange valences, we don't care about these signs, whether they are positive or negative. We don't care. Just we care about this number. The magnitude only we care. Okay, we don't care about the sign. So when they exchange, they will happen to be like this. Now Na1 ACl1, but it's very it's not very nice to write one like this. So we can. It's not nice. It's not that it's not nice, but we normally don't indicate that one. Okay, we don't indicate this number 1 when we are writing any product which has like this one. Okay, so we can straight away write it as just NaCl. Okay, but you will see in the next slide that if you have a value like 2 or 3, definitely you have to write those 2 and 3. But when you have something like 1, you can definitely exclude that 1 and just write the product. Okay, so NaCl, that's the way we obtained it. How did we obtain? We got the valencies +1, -1, exchange them. We don't remember when we exchange, we don't care about this sign, we only care about the number. All right, and then we were able to get this answer. All right, so we go to another example. In this example, we are trying to react potassium and oxygen. Okay, so potassium, again, it's in the first group, so it will have a valency of +1, whereas oxygen will have, oxygen is in the 6th group, so it will have a valency of -2. So we will carry out the same procedure. We have the valencies, we will interchange or exchange them between these elements, and we don't care about the sign. We keep the sign. We don't even want to be bothered about the sign. We just care about the number. So we do it, and we are able to obtain K2 oxygen 1, K2O1. But as I said, this one you can exclude, so we can just write K2O. Okay, this is called as potassium oxide. Remember, when you react potassium and oxygen, you are able to get an oxide, potassium oxide. Now here you react sodium and chlorine, and this is the symbolic form of sodium chloride. This is sodium chloride. Remember, in the previous video, I told you when chlorines react, what is the product? It can only be a chloride. So this is sodium reacts with a chlorine, so you are able to get sodium chloride. Okay, all right. Last example, this is aluminium and oxygen. We are reacting a different, a bit of a different kind of a example. So here we can see aluminium. If you see in the periodic table, it falls in group 3. So if it falls to group 3, it will have a valency of 3 plus or +3, you can say. No problem how you say it. And oxygen falls into group 6, so it will have a 2 minus or a -2. So we don't care about the sign when we are trying to interchange this one. So when we interchange, aluminum will get a 2 and oxygen will get a 3. Okay, so that will be the final answer. Okay, so that answer, now you get Al2O3. So when we get Al2O3, it is the name of this formula is aluminium oxide. So aluminium oxide, the symbolic notation will be Al2O3. Okay, and always keep in mind that these numbers we write as a subscript. That means we write below. See, I have always written this below. Okay, so don't write like Al2O3, don't write in the same line. The 2 should be small and should be a bit below the element. All right. Now there is a few things that we need to know about this, a few important notes that we have to make, because in certain elements, uh, when you compare them in the periodic table, they are a bit different when we have to react them. So there's a small difference. Okay, so for example, if you take this first table that we have here, these elements, if you see in the periodic table, they will be just O, just N, just Cl, just F, just H2. They'll be just. But when we include them in reactions, you cannot just include them uh, just the symbol. You have to always put a 2. See, we have always put a 2 here. Why do we put a 2? Because they are called as diatomic elements. Okay, so diatomic means you will always say di means 2, no? Di means 2, mono means 1, di means 2. That means every time it will have di, always 2. Always 2 it won't exist as single, or as mono atoms it won't exist. So keep that in mind when you're writing these elements, because these elements will be the common ones that will be given to you in your exams. And also there will be a few more ions that you will need to know, like for example carbonate ion, sulfate ion, these 4 ions here. You need to know how these ions, what are the symbols of these ions. So these are the symbols of these ions and their corresponding charges. So you can see this is 2 minus, so minus 2, similar minus 2, minus 3, and minus 1. Okay, so keep in mind these information, because those are very important for your in answering questions. Okay, keep in mind, because in case you write, and if you are told to write any reaction between say oxygen and potassium, but you have forgotten to include oxygen as a diatomic element, then you are wrong. Okay, here you might ask me why uh, it has not been done, because you can see straight away I have done here. What have I done? I have uh, here the reason is because we don't need to balance. Okay, so in any chemical equation we need to balance a chemical equation. That's what we're going to discuss in the next slide. So unless they tell you to balance, so when you're balancing equation, which will be definitely asked in your questions, then you definitely have to include them as diatomic elements. Just as examples for you all to show, because here our intention was just show you how to gain the product. That's why I did not include any diatomic atoms here. Okay, but when you in your questions, when you're answering any question, definitely include uh, them as diatomic elements. So let's see in the next few slides, there'll be definitely examples about that. So we come to the balancing of equation. Balancing equation is very important, because although you are able to achieve the correct product from the given reactants, if you leave it unbalanced, then it's not correct. Okay, only you're partially correct, you're not fully correct. So be mindful in always after you obtain a product to balance the particular reaction. That is very, very important. Okay, so when we say balancing reactions, now any reaction will have two sides, right? Separated by an arrow. So the right hand side and the left hand side, the element compositions should be same. So for example, if you have a reaction where you have two aluminiums on the reactant side, then the uh, product side also should have two aluminiums. If it doesn't have, then you should add any integer numbers. Integer means whole numbers. You can't add decimals, you can't add fractions. You can only add whole numbers, whole positive numbers, and you have to equal them. That is the task. That is the task when we say balancing any equation. Okay, so let's look at some examples. So here we have the first example where we are reacting carbon and oxygen. Okay, so when we react carbon and oxygen, you get carbon dioxide. Now in this first reaction, the reaction is already balanced. That means when we react these, the product that we get the composition of the elements on the product side and the composition of the reactants is same. Why do I say so? Let's see. Now on the reactant side we have one carbon. How many carbons are there on the product side? There is also one. How many oxygens are there? There are two oxygens. Here there are two oxygens. So the carbons are balanced, the oxygens are balanced. What else to balance? Nothing. So you leave it as it is. Okay. But is it so? If you are lucky, you will get something like that. But if you, but in most cases, you won't get balanced equation. You won't get. You will be asked to balance, like the examples following that. Now, for example, here you are trying to react sodium with chlorine. So actually when you are mostly when you are asked to balance any equation, you will be given this equation. Okay, and then only ask you to balance or do anything with it. Okay, so keeping that in mind, so you are reacting sodium and chlorine, you're able to get NaCl. Be mindful of this diatomic thing. So we have done that correctly. So we want to know whether this is actually balanced. So how do we see? We have to look at the composition of the elements on the right reactant side and the composition of the elements on the product side. So let's start from sodium. So on the reactant side, we have one sodium. On the product side, we have one sodium, right? So sodiums are balanced. Then what about the chlorine? On the reactant side, we have two chlorines. On the product side, we have only one chlorine. So that means the chlorines are not balanced. So how do we balance the chlorine? So here there are two, here there is one. So the simple thing you can do is add a 2 in front of NaCl. So when you add a 2 in front of NaCl, not only the chlorine gets multiplied, but also the sodium also gets multiplied. So now what has happened is sodium also has been multiplied by 2. So then what should you do? You should also change the composition here also. Here also you have to multiply the sodium by 2. Then if you see, two sodiums are here, two sodiums are here, two chlorines, two chlorines. All right. So whenever you're balancing, you can only add integers in front of an element. You can't add to the bottom of an element. Here you can't add, like that you can't add. You can only add in front of any compound or element. All right. So you can see the next example where we are reacting magnesium and nitrogen. We are getting this magnesium nitride. So here we can see, if you try to balance, this is not a balanced reaction. Why? Because reactant side you have one magnesium, here you have three magnesium, but nitrogen it is balanced because you have two nitrogens. So what do? Simply add a 3 in front of magnesium to make it balanced. Because if you add 3 here, you put a 3 here, you are getting 3 magnesium, and you have done the accomplished the balancing part. All right. So it's all about looking at the reaction, counting properly the reactants, the number of that element on the reactant side, and then count the number on the product side, and see whether they match. If they don't match, try multiplying it by various integers, and then you are able to get into and achieving balancing an equation. So it's basically you're playing with numbers. You're seeing, and then you are thinking a bit, and then doing the balancing part correctly. Okay. So in the next example, we are reacting nitrogen with hydrogen. So two diatomic molecules we are reacting, and we are able to get a product like this. So this is called ammonia gas. So in your next videos, you will see ammonia is a very important gas in chemistry. Okay. And then are they balanced? Let's see. So nitrogen on the reactant side we have 2, here we have 1, so nitrogen is not balanced. Hydrogen also is 2, Here we have hydrogen 3. So both reactants are not balanced. There's an issue. So what is the easiest approach that we can do? That is the question. So when you look at this, when you just sit and look at this, there is a small approach that you can easily do. Now, it is hard to balance the hydrogen straight away, because if you were to balance, I don't know, if you were to make this 3 hydrogens, what you should do is multiply this by 1.5. But we are not allowed to multiply by any decimals, right? So it should be always integer positive numbers. So the easiest part will be, you can either, like, I don't know, maybe make this 1, because here nitrogen is 1, so you can make this 1, but here if you are making this 1, you are divided by half. So once again it's a fraction, you multiply by half, so fractions again. So let's avoid the fractions, and you can simply, what you can do is, here you have 1 nitrogen, here you have 2 nitrogens. So simply multiply this whole compound by 2. When you multiply this whole compound by 2, you get 2 nitrogens and 6 hydrogens. Remember that you get 6 hydrogens. Remember that very well. Okay. When you put a 2 in front of this compound, the entire compound gets multiplied. Okay? The entire compound gets multiplied. Okay. Not only the nitrogen. So when the other compound also gets multiplied, that means there are 6 hydrogens on the right hand side. So here now we have 2. So how do we make a 2 into 6? You can just simply multiply it by 3. So if you multiply by 3, now let's see. Here you have 3. Okay. So in the, see the hydrogens here. So here as I said, 2 multiplied by 3, there are 6 hydrogens. So on the reactant side, how many will have? So here there is 2. So here you multiply by 3, then you have 6. Okay. So remember how you multiply this. Okay. Remember that very clearly. So the way we multiplied here and the way we multiplied here. Okay. The only thing that you now, this way you can multiply, like you can multiply this number by this number, you can multiply. But when we are adding any number to balance, we can only add those numbers in front of the element. Okay, we can't add them as subscripts. You can't add. Okay, so keep that in mind. Okay, because if you do that, that's wrong. So don't make that error. Okay. Next question. Now this looks like a very confusing, because you can see there are brackets also, and what did it mean? So let us see. Now this is a compound. This reacts with this and this, because here you have like the same element is in different places. You can see oxygen is in different places, hydrogen is in different places. So it might confuse you, but there's a very easy approach to this. Okay. Now, if you think, if you see this in the reactant side, you must first identify what are the elements found on the reactant side. So what are the elements that are found on the reactant side? You find calcium, you have oxygen, you have hydrogen, and sulfur. Those are the only elements found on the reactant side. So how, and then you need to identify in what proportion they are found. That is the next step. In what proportion those are found. So you can see that calcium is, there's only one calcium. Sulfur, there is only one sulfur. They are only one. But the other 2 elements, they have multiple times they are being repeated. So for example, here oxygen, now in this bracket, this 2 is for both of these elements. For oxygen and hydrogen, both of these elements are multiplied by 2. Okay, so be mindful of that also. So let's count the number of oxygens. Here you have 2 oxygens plus this 4 oxygens. So altogether you have 6 oxygens. So the reactant side you have 6 oxygens. And then hydrogens, From this bracket, you have 2 hydrogens. Here you have 2 hydrogens. So altogether 4 hydrogens on the reactant side. On the product side, you have 1 calcium, 1 sulfur, 4 oxygens here, 1 oxygen here. So altogether there are 5 oxygens and 2 hydrogens. Okay. So let's see what are the elements balanced, what are the elements not balanced. That's the only thing you have to find. So you can see calcium is balanced, 1 calcium, 1 calcium. Sulfur is balanced, 1 sulfur, 1 sulfur. Okay. The only thing that is not balanced here is, we'll see what is not balanced then. So oxygen there is 5, here you have 6. So oxygen is not balanced definitely. Then hydrogens, here there are 2 hydrogens, here there are 4 hydrogens. Okay. So it's a bit difficult here. Okay. So the how to approach it, that's the question. What numbers can you put here? That is the thing that will confuse you here. So our problem is the difference in these reactants and products will be the number of hydrogens and oxygens. So in that case, without even considering, without even adding any numbers in front of this, just worry about this water molecule. This H2O, just worry about that only. Why? Because this H2O is the only molecule in this entire reaction which only contains hydrogen oxygen. So hydrogen oxygen is the problem now. So let's deal with that problematic first. So in that case, you can just go on putting any number, go on with 2, and then see, go on with 3. If 2 doesn't go on with 3, go on with 4. So just go on with it, and it's a trial and error method. Okay, it might take some time, but the time you consume for it is very worthwhile, because you would definitely end up getting the right answer if you spend a considerable amount of time. Okay, so here after all that I have put here 2. So let's see whether 2 is actually correct. Okay, so if you have 2 here, you have 4 here, 4 hydrogens. Here what has happened? You have 2, 2. Yeah, right, 4 hydrogens, we've got it correct, right? So if you put 2, that means when we put 2 here, not only the hydrogen, the oxygen also gets multiplied by 2. So altogether there are 6 oxygens here on this side, and here there are 6 oxygens. So we have balanced it correctly. So in this case, we were lucky that we got that 2 really worked. Or else if 2 didn't work, we had to go on, adding different integer values and until the point where we get the correct integer value. Okay. So it's a bit hectic, but definitely worthwhile. Okay. The last equation, we are reacting hydrogen and oxygen to get H2O. So H2O is basically what the chemical uh, uh, formation of what is H2O. Remember that. Okay. So here also, if you can see the reactants, you have 2 hydrogens. Here you have 2 hydrogens. Hydrogen is balanced. Oxygens are 2. Here there is 1. So oxygen is not balanced. What you can do is, you have to maybe, as I told you earlier, without considering any fraction, without doing any nonsense with fraction and decimals, you can just look at it and do uh, by inserting any integers. So you can see here you have 2 oxygens, here you have 1 oxygen, so you can make this 2. How do you make this 2? Multiply this entire thing by 2. So this water molecule you multiply by 2. Once you multiply this water molecule by 2, not only will you get 2 oxygens, but you will also get how many hydrogens? 4 hydrogens. The composition of the hydrogen will change. So 4 hydrogens. So in that case, you have to convert this hydrogen here, as it will get 4 hydrogens. So how do you do? Multiply this by 2. So here you have 4 hydrogens, 4 hydrogens, 2 oxygens, 2 oxygens. Okay. So simple as that. So do as many practice as you can in this balancing, because balancing is very important. Balancing is a very needful thing. Okay, when we discuss about moles also, mole calculations is very important. So be very thorough in this, be very thorough in balancing, be very thorough in uh, getting the correct product. When you are given 2 elements, how to get the correct product. So all those, be very careful and be very considerate, and you will make minimal, in order to make minimal mistakes in doing questions. Okay, so that's it for this video. I'll meet you in another video. Thank you.